Okay, so here's the solution video for the problem I gave. Hopefully you tried it out and you can compare to what I got because I'm going to give you the full rundown of the conclusion to this. Overall, we have samples of American and Japanese teens. If you calculate the proportion in the samples, Japanese teens like anime at a higher rate than Americans. But is that enough evidence to show that the actual populations of Japanese Americans are different? Or is it believable that this difference is simply due to natural variation? So that's what we're trying to determine. To do this, we run a two proportion z-test, and I have everything involving that on the board behind the computer here. So that was the problem. So in similar fashion, showed all the same steps like before. I did the pre-work of finding the pooled number. Now, they didn't give me the actual proportions. They just gave me the success numbers. So in the example I did the opposite. I gave you the proportions and not the success numbers. So here, I used in the upper corner here, I used the success numbers to find the proportions. So basically, 28% of Japanese teens liked anime, where only 22.2% of American teens liked anime. This is a difference of 5.8%. Now, in order to work later in the problem, I need the pooled number. So remember, the p-hat pooled number is what is the overall anime liking rate. So I have it broken down by Japanese and American people. I want to know what it is in general, because remember, in the test, we're going to assume that the Japanese and the Americans like them at the same rate. So the pooled number joins together all people who like anime. So all people who like anime are a total of 147. All people totaled are the 593. So basically, all told, I have 147 people out of 593 who like anime. That is 0.248, or about 24.8%. So that's the general rate. Now I go on and do the test. Step one is to do the hypotheses. My null hypothesis is PJ for Japanese minus P sub A for American. I basically put the Japanese first because they have the greater total. So my assumption is the true difference between Japanese teenagers and American teenagers is nothing. That Japanese teenagers and American teenagers like anime at the same rate. If that's not true, I'll go with the alternative that when I take the actual American number from the Japanese number, I get something different than zero. There is some kind of difference between them liking anime. So my goal is to figure out, is there evidence that they like it at the same, like it at the same rate, or is the evidence pointing to the fact that they actually have differing rates in their population? To do that, I have to check the conditions. The independence condition in general is met. Now, there is a proviso here. I'd put one teen liking anime shouldn't affect another, especially between countries. Now, we would run into a problem if it was a small group, like we went to a school and there were a lot of people who were friends. Because clearly, if you're friends with somebody, liking anime could affect another student. In fact, I was a college student at the time, but I had a friend who really liked anime. Now, I didn't like anime nearly as much as him. Some I like, some I don't. But basically, he was the type, he loved anime, and he showed me some, and I didn't like all of them, but he got me into some that I wouldn't have watched without him. So clearly, one teen liking anime could affect another. But in our case, if we do our study right, if we pick people randomly and broadly, we're unlikely to get a group of friends where one affected the other. So just be careful that the study needs to be done correctly. That's why we don't want any kind of bias. If people do it correctly, it is likely to believe that from random picking across a broad group, that one teen liking anime wouldn't affect another teen in the sample. I put especially between countries because my example of my friend, influencing me on anime, I would be very unlikely to be influenced by someone in Japan. I mean, maybe nowadays it's more likely, given the ability to, communicate over long distances, but it's still not not very likely. So be careful with the independent condition. Here I'm just going to assume that if the people did it right, there should be very little chance of one person affecting another, especially between the countries. So the independence conditions met. The random condition, once again, we'll just trust the people doing it. For a real AP example, they would probably go into more depth explaining what happened. So I just put trust the people doing the study. The 10% conditions definitely met. 268 students is definitely less than 10% of all Japanese teens. And 375 people is definitely less than all American teens. So those numbers are clearly met. The success-fail condition is also met on all fronts. I used the p-hat pooled number and the q-hat pooled. Q-hat pooled is 0.752. Basically, I found the success rate using the p-hat pooled and the failure rate using the q-hat pooled, and those came out as 66,202 for Japanese liking and not liking anime, and then 81 and 244 for Americans liking and not liking anime. So all of those numbers are greater than or equal to 10. So since all of them fit the success-fail condition, all the conditions were met. So basically what this ensures us is the sampling distribution of the differences should be a normal curve. So once again, the one thing I didn't have room for, again, if you're actually doing an AP problem, you should now state what procedure you're going to do. So I would put after this, since all the conditions are met, I'm going to perform a 2-proportion z-test. That basically informs somebody that the way I'm going to test to see if the proportion is significantly different is through the work that follows. All right, so make sure in a real case that you would add that at the bottom, that you would put due to the conditions being met, I'm performing a 2-proportion z-test. So once I state that, and I've ensured that a normal curve works, I'm going to show all the mechanics. So like last time, let me move the board. There we go. So since I'm able to go ahead, here are the mechanics. Like before, my assumed mean difference is 0, and my actual sample difference is 5.8%. So I'm putting them on the normal curve. I'm assuming that my population has no difference. So if that's the case, most of the time I would get a sample difference near 0, and the farther I go out, the less likely I would see that kind of difference. So my goal is to figure out how likely is it, under the assumption that there's truly no difference in the population, what's the chance natural variation gives me a 5.8% difference. So I need to find this area, and since this is a two-sided test, I really need to find the area of both sides. So to do that, I included some of the other support numbers like the p-hat q pooled and q-hat pooled. I have my mean and I have my test value. I basically just need the standard error. I need to use the standard error pooled. So remember, I'm not going to use p-hat 1, p-hat, or p-hat 1, q-hat 1, p-hat 2, q-hat 2. I'm going to use the p-hat pooled and q-hat pooled in both slots. I am going to use the N1 and N2 numbers. So this is the number of Japanese, the number of Americans. I'm using that p-hat and q-hat pooled in both slots here. When I calculate that all out, I got a standard error of 0.0356. So now this is enough to get me a z-score, because basically I want to test how unusual is this result. Well, I'll take the result, subtract the mean, divide by the standard error. I get that this is 1.63 standard deviations out. Now, knowing about standard deviations, that doesn't seem terribly unusual, but we still need the p-value to make a final decision. So how do I get the p-value? I put normal CDF in the calculator. I tested from 1.63 onward. So what's the chance I get this result or something stranger? 0.0515. Now, since it's a two-sided test, I have to double the p-value. So I found the area of that part. I need to find the area of the other part as well. They're equal, so I'm just doubling it. So my p-value is 0.1031. Basically, what that means is if this is the null hypothesis, and it's true, that there truly is no difference, how likely am I to see a sample difference of 5.8% or stranger through natural variation? Well, it'll happen 10% of the time. So that's not unusual, right? I mean, it's not happening a lot, but that's definitely not under the cutoff of 0.05. So basically, this p-value is high enough where I won't reject the null hypothesis. This isn't evidence, even though the samples are different, it's not evidence of the population being different. So now that I have the p-value, this is how I make my decision. And then I have the decision I made and remember the context. So in step 4, I just say due to high p-value, I fail to reject the null hypothesis. What does that mean? By failing to reject the null, it means I have no reason to believe this isn't true, that even though the samples came out different, the population could very well have been the same. So I just put there's no reason to believe Japanese and American teens like anime at a different rate in general. Now remember, like with all tests, it's possible this test is wrong, but these procedures are correct most of the time. So this is the best we have to go on. So my conclusion, the big deal is the end, getting this number, this p-value, and then making the correct conclusion. So once again, the conclusion is that even though I have a sample difference of 5.8, it's not unusual to get that if the original difference was nothing. So this isn't rare enough for me to question the null. Therefore, I'm going to conclude that Japanese and American teens like anime at the same rate, or if it is a different rate, I have no evidence that it is different. Okay, hopefully you were able to solve this problem on your own. If not, try to work out where you might have went wrong. It's a lot of steps. It's a bit complicated, but hopefully you'll see most of the examples are the same. The only real difference you might run into is a one-sided test versus two-sided, but I've shown you 2 examples, one where you accept or fail to reject and one where you reject. I'm planning to put up the homework problems out of the book. Now, my problem is I know a lot of you may not have brought your book home with you and you can't go back and get it. So my goal is to give you book problems, and I'll snap a picture of the page for those of you who may not have the book. All right? Until next time.